Okay, second video on resistors. So wire wound resistors are manufactured to, they are a fixed type. I should mention that the difference between fixed type and variable is that all these resistors that I've already talked about here only have one ohmic value. They only have one value, and that is whatever it is manufactured to be at, of course within that tolerance range. So it's fixed. So a 100 ohm resistor should be manufactured to within the tolerance, 5 to 20% of its nominal value. Nominal meaning what the manufacturer has indicated on that resistor to tell us what it is, whether it's red, 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 or brown, black, brown, or green, red, whatever the colors are. The manufacturer is telling us what the nominal value is. So it's fixed, meaning it cannot be varied, versus a variable we'll talk about in a minute. Now, another type of, these are all fixed types, so carbon composition, film type, chip resistors, wire wound. Wire wound resistors are the most expensive type of fixed resistor, and they're actually made by wrapping a high resistance wire around a insulated cylinder. So the wire that they use, the length of the wire, so if you were to imagine this wire gets wrapped around here, so it gets wrapped around sort of like this, and the thickness of the wire and the length of the wire, obviously the longer the wire, the more resistance there will be in it. The thicker the wire, the less resistance. So the value of resistance is inversely proportional to the area of the wire, and it's directly proportional to the length of the wire. So we can vary the value that it is manufactured to by selecting the type of wire. And we know that, well, certain types of metals are better conductors than others. So if I wanted a resistor, wire wound resistor that had a little bit less resistance, I could either choose by using a type of material like copper over aluminum, so it would have less resistance per linear foot, and if I needed less resistance, again, I could shorten it, or I could increase the circular mill size of the wire. So again, it's inversely proportional to the circular mill size. So the bigger I make that wire, not the longer, but the larger the area or diameter of that wire, the less resistance. So the smaller the wire and the longer, the higher the resistance. They're generally expensive. They're used for more of a high current application. And as you can see, the cylinder tube is open over here. It's hollow. And typically these are actually mounted vertically. And for wire wound resistors, they're mounted vertically, and they have a hole in it to be able to dissipate that heat. So the hole has two purposes. The hole has one purpose in order to allow air to get in to the resistor, thereby increasing its circular, increasing its area around, whereby that heat can have air around it, and it can circulate and it can dissipate the heat, but also secondarily, as a chimney effect, it will be able to chimney that heat away. And again, typically used for more high current application. They can go, from fractional wattages up to hundreds of watts. So they're more expensive, probably the most expensive that are out there. And then we get to variable type resistors. So variable type resistors just means, well, I can vary this resistor, and this is the first one we'll talk about is a potentiometer. And a potentiometer is a variable type resistor, so meaning I can vary that resistance. And when you buy them, you go, okay, well, what range do I need for my potentiometer? Perhaps I need a 500 to 1,000 ohm range. Perhaps I need a 500 to 100,000 ohm range. So it really depends on what it is you're looking for, and you can vary that value of resistance. And what ends up happening is I'll show you the schematic for this. The schematic for a variable potentiometer resistor sort of looks like this. The schematic for a standard resistor looks like this. And a rheostat looks a little different. The rheostat looks like this. Okay, so you can vary the value of resistance here. This device right here, this thing here, is called the wiper. And the wiper is what actually you connect to your device. And so I have my power supplied to here and here, and this wiper will actually move back and forth along this value of resistance, and that will allow me to vary it. Potentiometer is a 3-terminal device, as you can see. And potentiometer comes from the word potential. Potential means voltage, and voltage is pressure. Voltage is controlled using a potentiometer versus a rheostat. A rheostat controls current. As you can see, it's just a 2-terminal device. So you want terminal 1 and terminal 2 over here. So a potentiometer can vary within, whatever your range you're looking for, and it's very easy to control. You just put a little terminal driver in there like that, and you turn it up or down. And a rheostat, same deal, like that. So a rheostat, again, is a variable resistor. A potentiometer is a variable type of resistor that is used to control voltage. And a rheostat is a variable type of resistor that is used to control current. I'll give you an idea of rheostat, where you find a rheostat. Typically in your car, you'll find a rheostat. So your auto dashboard light dimmer will, or a model car speed controller. If you ever had those model cars where it runs around the track, that's a rheostat. Video game paddle controller, those will use rheostats. Whereas potentiometers, probably the most common potentiometer you're going to come across is like a stereo volume control, that kind of thing. The potentiometer symbol, again, the schematic symbol looks like that. They're both, all these devices are used, considerably through electronics. And in our first lecture where we meet together, we'll talk more about these devices, and I'll take questions on this.